In this video, we're going to look at an example of distribution of sample percentages when n equals 8, where n is the sample size. So the histogram below shows a distribution of sample percentages for a sample size of n equals 8 and a population percentage of p equals 43%. The blue dashed line shows the location of the population percentage, and we're asked to complete the statement below based on this information. So first, let's get a feel of what this graph is representing. So I made up a context for us because it's easier to talk about these things when we put them in context. So I made up a trait and a population. So I'm going to say population is AZ residents, okay? And the trait is that they like action shows on TV, okay? So somehow, theoretically, we know that the true percentage of people in Arizona who like action shows on TV is 43%. And that's what this dashed line represents. Again, I made up this context. I have no idea what the true percentage is. Okay, so now let's look at our horizontal and vertical axes. So here we have the sample percentage on the horizontal axis, and on the vertical axis we have percent of samples. Okay. Now, this can seem very confusing because they both have the word percent and sample in them in a different order. So let's make sure we know what these represent. Okay. So here, the sample percentage is basically the percentage of people from a sample of size 8 that have this trait. Okay, so let's write these as fractions, and we like to write them as percents, and then we round them. These are actually mostly are not exact values, but that gives us a common way of talking about these values. But what this 0% represents is if you sampled 8 people and 0 out of the 8 people said that they liked action shows on TV, okay, then your sample percentage would be 0%. And this number, 1%, means that that happens 1% of the time. So 1% of all possible samples of size 8 will give you this result. Okay. Similarly, if you sampled 8 people and just one of the 8 people said that they like action shows on TV, okay, this would happen 7% of the time. 7% of all possible samples give us this result. Okay, so we can continue on. 25 is if 2 out of 8 people say they like action shows. Here we have 3 out of 8. 50% is 4 out of 8, which is a half. 5 out of 8, 6 out of 8, 7 out of 8, and 8 out of 8. Okay, so these are all the possible samples you can get. If you ask 8 people that are Arizona residents, say we get a simple random sample of 8 people, do you like action shows on TV? Either 0, 1, 2, 3, 4, 5, 6, 7, or all 8 of them will say yes, and these are the fractions you can get. And these percentages are percentages rounded to the nearest whole number of these fractions. Okay. Now notice it says 0% of all possible samples will give you 100%. This is rounded, so I just want you to note that this is really small, enough that we'd round it to 0% instead of 1%, but it is not impossible, or not impossible. Okay, so it's completely possible that you can pick 8 people and every single person in your sample says they like action shows on TV. Okay, so again, this is the result of rounding. Okay, so looking here, again, this is the percent of samples. Okay, so that means 1% of all possible samples will give you 0% of the people saying they like the action show, like action shows on TV. Okay, here we can say 27% of the possible samples will give you 3 out of 8, which happens to round to 38% of people who like action shows on TV. Okay, notice the true value is 43%. You can actually not ever get a result of that with n equals 8, so you can't get the true percentage, the true population percentage, okay? And that's because no number divided by 8 equals 43%. And we usually use larger numbers for our samples, but then it makes it harder to interpret it like we can with this small one. Okay, and now the question I'm going to ask is pretty simple, or the question we're going to do right here, but I think it's good to, instead of just saying add these three numbers, to try to get a feel of why we're doing what we're doing and what it's coming from. So the question says, if we find a sample of size 8 and the true population percentage is 43%, so basically we're finding one sample from all of these possible samples, okay? The percent of samples that lie between or equal to 38% and 63% is blank. Okay, so again, watch your terminology. Notice it says the percent of samples. Okay, so that's what we're trying to find. That's the vertical axis. Okay, and we're going to put that value here. And these values that lie between or are equal to, that's the sample percentage. So let's use different color just to highlight these. So here's 38%, 50%, 63%. Okay, and their corresponding percent of the total amount of samples is 27, 25, and 15. Okay, so if we add up these values, which I'll do right here, 27% plus 25% plus 15%. Okay, this is 25 and 15 is 40, plus 27 is 67%. Okay, so that is our answer. Okay, so the percent of samples that lie between or are equal to 38 and 63% is the sum of the percent of samples that fall into those categories, which is 67%.